So here with the oil dampener. Now this thing works by, as this goes up and down with the wheel travel, it rotates this shaft, which in itself has got a cog on it, or a gear. It goes like that, and that then has got a piston in here with a rack on it, and that forces that piston up and down, and it basically circulates oil. As the piston comes up, it forces oil up through a little hole, and then this here changes the size or the aperture diameter, allowing the oil to pass or not, and that hardens or softens the suspension by restricting the oil flow. It does work quite well. This one is leaking, unfortunately, at the bottom. It was working fine, but I'll show you if I rotate this to soften the suspension. You'll see it'll allow oil flow to go. You'll see that the arm will start to drop. See as the oil leaks out. And when this is working properly and it's completely full of oil, that will obviously sit high up here, and then as you release that, it will move up and down with the restriction of the pressure against the oil like that. Let's do it again. It's nice and soft. Down she goes. Now in here there's a couple of oil seals around these bronze bushes, and you can see it was working fine, but when we start giving a bit of pressure, unfortunately, we get the oil come out. So guess what? We're going to have to take it apart, like we haven't taken the whole bike apart. Right, to get this off, you need to get all the cakey paint off of there. Take out these two screws, one either side, and they're proud into the bronze bushes that are in here. So you take those two out, that will release the bronze bushes. There's often an oil cell around here as well, and then you just have to knock it out one way or other, push it through from in there, and then we'll have a look at it. Right, so I've got it apart. These are all the parts you need for one of these. So it's not, whilst it looks a bit rough, it's actually not bad order. The main body is actually in pretty good order, so certainly usable. I don't need to do any engineering on that, which is some good news. So this is the dampener control. As you can see, there's a slight slot in it there. So as you turn that left and right, it opens and shuts an aperture, or allows fluid or oil to leak around there. On my last one there was a gasket on here actually, but there isn't on here, so I would put an O-ring or some kind of compression seal on there. Put that in there for a minute. This is normally longer as well. For some reason this one's been cut off, or probably broke off, and someone's just filed it down to make it look tidy. Right, so then down this end we obviously have the splined or semi-splined shaft here, along with the piston plunger, which obviously goes on like that, and as it rotates goes up and down, as I explained earlier. And the end of here is a ball bearing stuck down in there, which acts like a valve. Right, so on this end we have obviously the main connection arm, followed usually by some kind of washer type thing. And I say that because they don't always seem to have them on there. But so that goes on first, just acts as a seal. And then obviously the wood rough comes out next, followed by the oil seal. Now this is obviously one of these horrible old metal ones, and it's huge, so it's about 1 mil oversized. It's through a combination of wear of the oil seal hardening and wear on the shaft. This is a it's an 18 by 28 by 7 double lipped or TC oil seal. It's the best one to get for that. 2 of them obviously. Followed by what is usually a phosphor bronze bushing, something like a PBO2 type of phosphor bronze. This case it's probably an original one. Now I always thought they were solid bronze, but this one appears to be steel with someone's put a bronze insert in there. Which in some respects makes it a bit easier to repair, because I can just bash that out and make a new phosphor bronze insert for it. And finally there is a thicker washer with a bevel on it, and the bevel faces that way to butt up against there. Now, so the key point with these is that this shaft area here needs to be 18 mil all the way along. they obviously wear out quite a lot. Weirdly enough, this steel on the shaft, I'm going to try and show you this, appears to have worn more than the phosphor bronze, or the bronze inside the actual bushing, which is a bit strange. Oh, you can probably see it better on this one. I don't even quite make it out. I think just to see there's a lip there on this side. One of these other sides is nowhere near as bad, and you can't there. So you can see it's nice and straight across there. As I rotate it, there's a wear section there, and that's apparently reduced it. I measured it down to about 17.8 mil. So we're going to have to repair that. You can buy a new one of these. Michael Akener will sell you one. It's about €100, having looked at his website. And I bought one from him before, and it's a pretty good job, to be honest with you. It's spot on. Slightly oversized, I think, but I can't say whether the bushings were undersized or they were oversized. But either way, it did the job. So that goes on there, and luckily you can see where the oil seal, the new oil seal is going to sit, which is around this neck of the woods. The surface is uniform, if not slightly rusted in appearance, but at least that's pretty good. So to repair this, you've got a couple of options really. You can either buy a new one and buy a new set of bushings, or you can build up the lost section there. It's actually not that too difficult, to be honest with you. I did it on a lathe with the MIG welder. I did try to be clever once and have the lathe going whilst MIG welding it, and very slowly of course, and it did actually come out surprisingly well, albeit slightly dangerous. So I'm going to build up the shaft on this, and then I'm going to re-grind it to 18 mil. This is not a high-speed component in any way. It just literally travels about 90 degrees in rotation, if that, so it won't be a problem. It's a bit time-consuming to build up this, and then I'm going to resurface the whole lot back to 18 mil. Measure out these bushings. If needs be, I'll press them out, press in some new ones, put it all back together, and it should be nice and oil tight. When it is working properly, it's a very effective device, this. Albeit, in my opinion, completely and utterly over-engineered, but that's part of what you love about these German bikes, no doubt. Right, there it is. Wasn't a quick job, that. Anyway, we're good to go now. So up first, we're going to remove the original bushings in there, which appear to be brass, looking at not bronze. Either that or they're gold, but you know. You could press these out, but they're a bit thin. Makes hard work pressing them out, really, in terms of fiddly. It's easier just to bore them out like this and just chuck some new ones in. Put a little bit of heat on this, and now I'm just going to press it in. So I've made it about 2 thou, which is 0.05 millimeters oversized, because it's a bit of a job to press it in, but we'll force it in there and have a nice tight grip. Right, we're good to go at last. So we've got some new bushings that I've made here. We'll talk about those in just a second, as you've seen. That's the other one. Now, let's have a quick look at this first. So this is all cleaned out. You have to make sure that you clean right up there, and at the bottom there's like a dead end, which often collects a load of sludge and goo, which when you put new oil in drops back in and blocks all the holes, to make sure that's completely spotless. Likewise down that channel, and of course down here. Over here we've got the where you often see a grease nipple or something like that, and I don't think that is for a grease nipple, because I can't really see what you'd want to do, why you'd want to pump grease in there when you put oil in the top anyway. I think that served nothing more than a block off hole, because they inserted the drill up through there, so the drilling goes at that sort of angle straight through the case, down at that angle, changes down there. There's a drilling that way to complete the circle. So this obviously goes back in this way. So this axe plunges on the downstroke to stop the resonance, if you like. So what you don't want to do, of course, is get into a resonant frequency, a low frequency resonance when you're riding a motorcycle of any description, because you'll soon come worse off for that one. So this is cleaned out. Make sure the ball rattles, which you can now. Pour petrol in it, like I said, is the best way. Check the wear on there. These teeth mesh quite nicely. It looks a little bit rough, but it'll be absolutely fine for this. So this has now been machined, as you saw, and welded it back up, and then turned the weld back down on the lathe. Now the weld can be a bit tricky to turn down. You can't, it's a bit difficult to get exactly the same finish sometimes. If you use those index carbide tips, they just shatter, in my opinion. They just blunt. They don't like it when you've got a slightly choppy surface or something like that. You're better off to use a carbide solid tool or tips tool. Right, so I've made these, the standard size is 18mm, and I've made them 17.5. The reason I did that is because, one, I got bored welding it all up, and two, when I went over it, when I took it down to 18mm, there are still a few little tiny little divots in it, and it's a bit risky if you keep on weld, cut, weld and stuff like that, because eventually you're going to get a bit of a warp in it. Unfortunately, I did get a very slight warp in it, but I managed to take it out of the weld as well. So it's not going to be a real problem. That's now sorted anyway. We're only talking about maybe half a mil or something across, or a mil across the length, maybe less than that. So these are now 17.5. So we've got the oil seals here, which were, the standard ones are 18 by 28 by 7. And I've now gone for 17s by 28 by 7. Just to give a slightly tighter fit. It's obviously a 17.5mm shaft, so they're going to be even tighter than that. Now the only problem we've got with this, of course, is that when they go into these ends, like so, you can see there's going to be a little bit more play than normal, so I may have to put a shim in there. I don't think these will grip tight enough to lock onto them, so I'm going to put some 0.05mm shim steel in there, just wrap them around and clamp them tight on there, and that will grip it nicely. Obviously 2 halves, because we've got a wood rough in the way. Assembling this is a little bit trickier than you might think. You kind of instinctually think, I'll just chuck it all back together and it's good to go, but without those marks telling you where to put it, it's actually quite difficult. So the procedure is, you assemble this part first, and you want to end up with it with the wood roughs. This is going from memory here, pointing slightly off of horizontal, slightly down. So you need to put this in, and then you need to work out that when you wind this like that, where it sits in this kind of action. And I think from memory you start with that probably about horizontal, but on the opposite way. Then insert this, catch it on the first tooth, then wind it up, and it should sit about there, I think. So I'm going to have a fiddle around with that, see where we get to. Then we can bash in all these bits and bobs. Might be an idea to put these rings in first, because they help sort of centralise it a bit. And then rotate it around, and then we'll, if we're happy with that, we'll hammer it all in. And if not, we can always drop this out the bottom when it's in the bike. Disconnect it from the frame, from the fork, and just rotate it around and do it again. But it is a bit fiddly, unfortunately. And I meant to mark this when I took it apart, and did I remember? Nope. Right. So after a bit of fiddling around, it appears that the best sort of starting position you could have is for the wood rough to be pointing straight down, and the piston corresponding with the first couple of threads. You can just see it. And that appears to give me the best range of motion, that when the piston sits in there just above the hole, that which is roughly where the bike will sit, the range of motion will be from there to about there, because it'll hit the plunger, which equates to about, I don't know, and it just seems to look about right. So it's about that kind of a motion. So I'm going to go with that. Then I'm going to pull this together now, put the seals in. I'm pretty confident it won't leak, so I'm hoping it won't. And then I might test it. If not, we'll test it on the bike. So, but like I said, I'll probably just put it together now and give it a little test and see what happens. See if it works better. So just the final thing on assembly I meant to point out was that when you put these back in here, these bushings, make sure that the holes line up, because even if they're slightly out, it can be a little bit tricky to rotate them and get those grub screws back in. You end up hitting them in and out all the time sometimes. And likewise, when you're pushing these in, be careful they don't rotate slightly. That's happened to me once. Right, that's it. Go ahead. I'm going to push them back in now, seal it all up, fill it with oil, and see what it does. Okay, it's all back together, filled with oil. So round that way should be looser if we press this down. There we go, shaking the table. That works fine. Slow to go up. Press it that way. Nothing, it won't even budge. Right, so it won't even budge if we go down that way. It's absolutely solid, which is good. Let's put it back around to that side. Down she goes, which is quite nice. I'm happy with that. It's a little bit tighter, I will admit, than I wanted. But I'd rather it was tight than loose, because if it was loose, we'd have more risk of oil spraying everywhere. And look, I don't even have the oil seals in yet. There's a little bit of weepage around that one, but nothing major. The oil seal, but it's dry around the actual shaft itself, which is good, so you've got a good fit. And then around this side, let's get this off. No oil seal in there at all. And it's bone dry, which I quite like. But what will obviously happen is you'll get a bit of wear in there sooner or later, and a little bit of oil will start creeping in. But overall, pretty happy with it. Need to, the only thing which is annoying is that side. I need to bash that side in there a little bit more, because if you notice, I don't know if you can see that or not, but down in there, that's not quite lined up. So I'm hoping that's going to go in okay, because the one on that side, the hole was slightly offset, and I had to guess as to which way around you put it in. And it'll be sod's law, it'll be the wrong side. But so that's it. That's the oil dampener done. Engine's up next.